Welcome back to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the world of Kubernetes. Before we start, we'd love to hear from you. If you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
That's right, Sheila. Your feedback helps us improve and reach more people interested in learning about Kubernetes. Now, let's get started with today's episode.
Absolutely. We're continuing our Introduction to Kubernetes season, and we're starting a new chapter called Getting Started with Containers. Today, we'll be focusing on the introduction to containers. But before we dive in, I have a quiz question for our listeners. Are you ready, Victor?
I'm always ready for a good quiz, Sheila. Let's hear it.
All right. Here's the question. According to a 2021 survey by the Cloud Native Computing Foundation, what percentage of organizations were using containers in production? Was it 25%, 50%, or 75%?
Wow, that's an interesting question. It really makes you think about how widely adopted containers have become in recent years. I have my guess, but I won't spoil it for our listeners. What do you think, Sheila?
I have my suspicions too, but let's keep our listeners guessing for now. We'll reveal the answer at the end of the episode. For now, let's start by explaining what containers are. Victor, could you give us a basic definition?
Certainly. In simple terms, a container is like a lightweight, self-contained package. It includes everything needed to run a piece of software: the code, runtime, tools, and settings. Think of it as a standardized unit of software that can run consistently on any infrastructure.
That's a great explanation, Victor. It reminds me of shipping containers used in logistics. Can we draw an analogy there?
Absolutely, Sheila. That's a perfect analogy. Just like shipping containers standardized global trade by providing a consistent way to transport goods, software containers standardize software deployment. They package everything an application needs, making it easy to move between different environments, whether it's a developer's laptop, a test server, or a production cloud environment.
That makes a lot of sense. So how do containers differ from traditional deployment methods, like running applications directly on a server or using virtual machines?
Great question. Unlike traditional deployments where applications might clash due to different versions of tools or libraries, containers provide isolation. Each container runs in its own environment with its own set of libraries and dependencies. This isolation prevents conflicts and makes applications more portable.
And compared to virtual machines?
Containers are more lightweight than virtual machines. While VMs emulate a full operating system, containers share the host system's OS kernel. This makes containers much faster to start and more resource efficient. You can run many more containers on a host than you can VMs.
That's fascinating. Can you break down the components of a container for us? What makes up a container?
Sure thing. A container typically consists of several key components. Point 1. Container image. This is a lightweight, standalone package that includes code, runtime, tools, and dependencies. Point 2. Container runtime. This is the software responsible for running containers, like Docker or Containered. Point 3. Namespaces. These provide isolation for processes, networks, and file systems. 4. Control groups, C groups. These limit and isolate resource usage like CPU, memory, disk I/O, and network.
Wow, that's quite complex. Let's take a step back. What are the main benefits of using containers in software development and deployment?
The benefits are numerous, Sheila. Point 1. Consistency. Containers ensure that applications run the same way in any environment. Point 2. Portability. They can easily move between development, testing, and production environments. 3. Efficiency. Containers share OS resources, making them lightweight and fast. 4. Scalability. It's easy to scale applications up or down by adding or removing containers. And 5. Isolation. Applications in containers don't interfere with each other or the host system.
Those are impressive benefits. Can you share an interesting anecdote about early container usage?
Certainly. Did you know that the concept of containers dates back to 1979 with Unix v7? The CRUT system call was introduced, which changed the root directory of a process and its children to a new location in the file system. This was a primitive form of the file system isolation we see in modern containers.
That's fascinating. It's amazing how long these concepts have been around. Now let's address some common misunderstandings. One I've heard is that containers are just lightweight VMs. Is that accurate?
That's a common misconception, Sheila. While containers and VMs both provide isolation, they work differently. VMs virtualize an entire machine down to the hardware level, each with its own OS. Containers, on the other hand, virtualize at the OS level, sharing the host OS kernel. This makes containers much more lightweight and efficient.
Thanks for clarifying that, Victor. Now, as we wrap up, could you share some best practices for working with containers?
Absolutely. Here are a few key best practices. Point 1. Keep containers small and focused on a single service. 2. Use official base images from trusted sources. Point 3. Don't run containers as root unless absolutely necessary. 4. Use environment variables for configuration. Point 5. Implement proper logging and monitoring for containerized applications.
Those are great tips, Victor. Now, let's reveal the answer to our quiz question. According to the 2021 CNCF survey, what percentage of organizations were using containers in production?
The answer is 75%. That's right, 3/4 of organizations surveyed were using containers in production. It's a testament to how quickly container technology has been adopted in the industry.
Wow, that's impressive. To summarize today's episode, containers are lightweight, portable units of software that package code and dependencies. They provide consistency across different environments and are more efficient than traditional VMs. Key components include the container image, runtime, namespaces, and control groups. Benefits include consistency, portability, efficiency, scalability, and isolation. Best practices include keeping containers small, using trusted base images, and implementing proper logging and monitoring.
Excellent summary, Sheila. In our next episode, we'll dive deeper into Docker basics, so stay tuned.
That's right. And remember, if you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy containerizing.